My son who took the SAC entrance 6, he gave me this problem, and this problem has been to be related to my previous video about the arc length. Let's see how we can solve it mentally, and we can solve it by geometry. The easiest way is to solve it using the inscribed angle theorem. For those students who know this theorem, then they just actually using the calculator, plug it in without any paper and pencil, without any additional work, and boom, in 5 seconds they can actually figure out the answer. But let's go slowly to make sure everybody understands it. The inscribed angle theorem states that any inscribed angle within a circle equals half of the arc. That angle intercepted equal half of the intercepted arc. For this angle XYZ equal 142.1 degrees, this angle intercepts the arcs XZ, not passing through the point Y. Therefore, the arc XZ not passing through the point Y, based on the inscribed angle theorem, equal twice the angle XYZ, which is twice the angle 142.1 degree, equal 284.2 degree. The other arcs from X to Z not passing to Y is the total arcs XY plus XYZ, and this total sum of those two arcs equal the full 360 degree minus the remaining arcs of 284.2 degree equals 75.8 degree. Okay, so mentally speaking, the student just get a calculator and plug in this number, do the 2 times 142 degree, and then subtract from 360 and get the answer 75.8 degree in 5 seconds, depending on how fast you use the calculator, right? So this is the step by step how mentally thinking and using the calculator to figure out the final answer. Now let's see how can we find the answer without using the inscribed angle theorem. For some students they know this theorem, then boom, they figure out the answer. But what others who don't know the theorem? Well, if they know a little bit about geometry, they can also do that too. Let's take a look at this picture and consider the angle, the triangle YOZ. You have the angle YOZ equal 180 degrees, subtract the other two remaining angle, which is YOZY and OYZ. Since this is the radius are equal, therefore OZY equal OYZ. Rearranging, then we have YOZ equal 180 degrees, subtract 2 angle YOYZ. Similarly, we can apply the same concept for triangle XOY. We have the angle YOX equals 180 degrees, subtract twice the angle OYX. Combining equation 1 and 2, we have XOZ equal YOX plus YOZ equal 360 degrees minus 2 total angle YOYX plus OYZ. But since the OYX plus OYZ equal the angle XYZ, rearranging, we have the angle XOZ equal 360, subtract 2 angle XYZ and plug the number in, we have 75.8 degree. So for students who don't know the inscribed angle theorem, they can use geometry. Using geometry, they probably use the additional work on paper and pencil by drawing the picture, marking the angle, and doing some algebra along the way. But if they can do it fast enough, they can actually get the answer in 30 seconds, within 30 seconds. And even for students, they don't know the inscribed angle theorem, they know geometry, they imagine well in their mind about the figure, then they actually don't need paper and pencil, right? Because this geometry, very simple geometry, they can imagine the entire figure in their mind, and then you calculate and plug in the number.